right, here we go. We're on number 4. So the first thing we're going to do is the directions were to write a polynomial function of least degree with integral coefficients that has these as the zeros. So these numbers right here are the zeros. This is where my function goes through the x-axis. So we start by changing these into factors. If 2/3 is a 0, that means x minus 2/3 is a factor. If -1 is a factor, x minus -1. It's the same thing as x plus 1. If you've got -5, we're going to make that plus 5. So we're going backwards from some of the factoring stuff we learned. Legitimate question?
Wouldn't it be 3x minus?
We haven't got there yet, but yes. So you're going to bottoms up so that we don't have any fractions, because that was in the directions. 3x minus 2, x plus 1, and x plus 5. So this part, not too bad. The only thing that makes this complicated is trying to multiply everything out. We start by using FOIL method to take 3x minus 2 times x plus 1. So 3x times x is 3x squared. 3x times 1 is 3x. -2 times x is minus 2x. -2 times 1 is -2. I'm going to clean that up before I multiply it by x plus 5. So put the like terms together, slap some parentheses on it. 3x squared plus x minus 2, and then I'm going to bring down the x plus 5, and I have to multiply all of this by that, and then we'll be done. So we'll take 3x squared times x, which is 3x cubed. 3x squared times 5 would be 15. X squared, put a plus sign in between to separate terms. Then I move on to x. X times x is x squared. X times 5 is 5x. Move on to -2. -2 times x is -2x. -2 times positive 5 is -10. So we're going to combine these like terms and decide what we want to call our function. I'll call this one g of x. So we'll have 3x cubed plus 16x squared plus 3x minus 10. And we're all done. So far, not too bad. We've done some with integers. We've done some with fractions. We know how to deal with those. On the next page, when we switch to radicals and complex numbers, it'll be a little bit more exciting. So let's do that. If you have 4 in the square root of 7, when we talked about finding roots, if I have square root of 7, we're going to write a little note that square roots come in pairs. It's always plus or minus a root. I'll put a little bubble around that as sort of a special note. So if I have the square root of 7, I also have negative square root of 7. I have to add that in using my knowledge of how these roots work. If you have one, you have to have the other. I always thought of it as the textbook writer's way of being lazy. We're just going to give you one of them, and you're supposed to know there's another.
Don't pears grow on trees?
All right, so let's make out our factors then. So we're going to have x minus 4 as a factor, x minus square root of 7 is a factor, and x plus the square root of 7 is a factor. Now I'm going to give you a tip. We are going to multiply the radicals first. So I'm going to put a little note, multiply first these. And there's a reason for that. When we multiply these out, the radicals are going to go away. So I'm just going to drop down the x minus 4. I'm not going to go from left to right on this one, and it's okay. You can multiply these in any order. So I'm going to do x times x, which is x squared. X times the square root of 7 is the square root of 7x. And then negative square root of 7 times x is negative square root of 7x. And guess what? Those cancel out. Then I have negative square root of 7 times positive square root of 7. So it's going to be negative, and square root of 7 times square root of 7 would just be 7. It's a square root of 49, comes out 7. You're squaring a square root. So essentially all this is going to be now is x squared minus 7. That's a cool thing that happens with radicals. It actually Isn't that bad if you do these first? If you don't do these first, this is a monster. I promise you don't want to have that many terms to multiply with square roots in there. So now we've just got to use FOIL method to multiply these. So x times x squared is x to the third. X times negative 7 is negative 7x. And I'm going to write that over here so I can put these in order. Negative 4 times x squared is negative 4x squared. So I kind of went out of order so I could do those in the right order on my answer. And then negative 4 times negative 7 is plus 28. And all we have to do is name our function. Let's call this one d of x, just for fun. And you wouldn't necessarily have to reorder these. I just like to have them in order in case I have to do something else with them later. All right, so I purposefully made each of these on this page a little bit different so that you'll have to pay attention, or so if you don't, you'll lose stuff. Okay, so I have 2 different square roots here. If I have 2 square root of 2, I also have negative 2 square root of 2. If I have square root of 10, I also have to have negative square root of 10. So we add these on because they have to come in pairs. If I'm square rooting to solve something to find the roots, there's always a plus and minus. When we write them out, we want to make sure that we are pairing these up. So I'm going to do x minus 2 radical 2 with x plus 2 radical 2. And then I'm going to do x minus square root of 10 with x plus square root of 10. And we're going to multiply these and these separately so that all the radicals drop out. If you are really bored and you need more work to do, you can multiply these in a different order and keep track of the radicals all the way through. But if you multiply these together and these together, the radicals will completely drop out and your life will be a little bit easier. So if I multiply these out, x times x is x squared. X times 2 radical 2 is 2 radical 2x. Negative 2 radical 2x happens next, so those are going to cancel. And then I'm going to have negative 2 times 2 is 4. Square root of 2 times square root of 2 is 2. So I'm actually going to have to multiply that together to get x squared minus 8. So let me talk about that last part again. You multiply the numbers on the outside. 2 times 2 is 4. You multiply the radicals, which cancels out the radical and gives you 2. Just why we spent so much time on radicals in previous classes. All right, so then over here, I'm going to kind of put parentheses on that so I can do this part. We're going to do x times x is x squared. I'm going to have plus square root of 10x minus square root of 10x. And then negative square root of 10 times positive square root of 10 is going to be minus 10. And these in the middle cancel. So I'm just going to have x squared minus 10. And if you group these like I did and multiply them the way that I did so that all the radicals fall out, all you're left with is one more time I have to use FOIL method to multiply this out. X squared times x squared is x to the 4th. X squared times negative 10 is negative 10x squared. I'll have negative 8x squared. Negative 8 times 10 is plus 80. So combine like terms. We'll give this one a name. I'm going to call this one, sure, q of x is x to the 4th. It's going to be minus 18x squared and plus 80. So you do need to have some sort of name for your function over here. They don't tell us what we're supposed to call it. So since actually theoretically you wouldn't even have to use x. You could make these t's or a's or whatever you want. I always use x because most people are comfortable with that, but they don't even tell you what letters to use. You could switch and use all different letters if that tickles your fancy. I'm sure it does. All right, so that's how you do radicals. We're going down now to look at what happens if we have complex roots, which means we have i's. So down here on number 7, I have 4 and I have negative I. So just like radicals, because I is technically the square root of negative 1, i's also come in pairs. So I'm going to put a little note there. So if I have negative I have to have positive I. So I added this.
Isn't that like a square root of 1?
Square root of negative 1 is I, yes. And then this would be negative square root. So anyway, it's because we have plus or minus I. Whenever we solve equations, when you get imaginary roots, we've seen with what we did before that you're going to end up with those in pairs. All right, so the first part's easy. I'm going to have x minus 4, and then we do the same thing with the i's. I'm going to have x plus I, x minus I. We do want to multiply the part with i's first because we can get rid of all imaginary numbers, and that makes life a whole lot easier. So, if we multiply this out, x times x is x squared. X times negative I is negative ix. I times x is positive ix. Positive I times negative I is negative I squared. This middle part cancels. I squared is the same thing as negative 1. So basically you have x squared minus negative 1, which makes this x squared plus 1. He's not wrong. And then we'll bring down the x minus 4 that's been waiting patiently for us to do something to bring it back into the function. So now we just need to use FOIL method, multiply this out, give it a name, and we'll be done with this one. Okay, so x times x squared is x cubed. X times 1 is x. I'm going to write that over here so I have room for the next part. Negative 4 times x squared is negative 4x squared. Negative 4 times 1 is negative 4. And I'm going to call this one f of x again in the front. Now the last one I saved for the end because it is the most complicated and it is different than this one. I didn't think we were going to have time to do a million of each of these, so we are going to look at this. So this one is just regular imaginary numbers, the negative 2i. We can add positive 2i. With this one, we have to add the conjugate.
What?
Yep, which is something we've talked about way back when we first learned about i's. So instead of changing everything, I'm going to make it negative 2 minus 2i, which is what we used to get it out of the denominator when we had to rationalize these. So you keep the first part, but you change the sign on just the I part. So you only change the sign on the I part. And that is what makes this one slightly more complicated.
This is awesome.
And this is going to be a little bit of work. Question. Okay, you got it? So you have to make sure that everything with an I has a pair. If it's a complex number with a real and imaginary part, the real part stays the same. Imaginary part, you do the opposite sign. All right, so when we do our factors, we are going to have x plus 2i. We're going to have x minus 2i. And here's the exciting part that we have not done at all today. We're going to make brackets because I need to have parentheses inside of brackets. We're going to have x minus parentheses negative 2 plus 2i. And in brackets, x plus parentheses negative 2. I have to think about this. This is supposed to be that's why this is supposed to be minus. I got confused. And then minus 2i. I changed this to plus, that's still minus. Okay. So, a little bit exciting. Let's do the part that we know first. So x plus 2i times x minus 2i. We're going to use FOIL method to multiply that out. So we get x squared minus 2ix plus 2ix and then minus 4i squared. So this is going to cancel. This is going to give me negative 4 times negative 1. Just going to change it to plus 4. So this factor is going to be x squared plus 4. That part's done. All right? This part is going to be kind of a pain in the butt.
Oh, yay.
So the way, I've done this several ways, the way that my students in the past have liked this done the best is to distribute this minus sign out first. So that's what we're going to do. We're going to make it x plus 2 minus 2i. So we can get rid of those parentheses, and x plus 2 plus 2i. So that we essentially have 3 terms and 3 terms we can just multiply out. You can do this in other ways, but this has been the most successful that I have seen with other classes. So when you go to multiply all of this out, we take x times x, so you get x squared. X times 2 is plus 2x. X times 2i is plus 2ix. So I take this x times all of these. Then I'm going to take this 2 times all of these. So I'm going to have plus 2x plus 4 plus 4i. And I'm running out of room. So I'm going to take the negative 2i times all of these. I'm going to get minus 2ix minus 4i and minus 4i squared. So there's a bunch of stuff here that's going to cancel. 2ix and negative 2ix go away. Negative 4i and 4i go away. I squared is negative 1, so this part on the end is going to become plus 4. So I'm going to change that to plus 4 and cancel this out. And then you just collect all of the like terms. So we'll have x squared. I have 2x and 2x that goes together. 4 and 4 that go together. So you have x squared plus 4x plus 8. And then you have to multiply that out, and you'll be closer to done.
Wow. Closer.
Closer. We still have a little bit of multiplying and combining like terms, but you guys said that part was easy. So x squared times x squared is x to the 4th. X squared times 4x is plus 4x cubed. X squared times 8 is plus 8x squared. 4 times x squared is plus 4x squared. 4 times 4x is 16x. 4 times...
4x cubed.
Yeah, no, wait.
Wait, no.
No, it's...
I wrote it wrong.
I already did that one. So this one was there.
Yeah, I wrote it wrong.
And then 16x. And then plus 32. All right, we just have to combine like terms and name it, and we'll be done. Did I leave anything out? I think it's okay. So it's x to the 4th plus 4x cubed plus 12x squared plus 16x plus 32. And we have to name it. I'm going to call it g of x just because that comes after f, which is what I used in the last one. It does just take a lot of work.
This is